Have you ever wondered why Java's garbage collection is so powerful but never uses reference counting for that? What if I told you that relying on reference counting could break your program entirely? Stick around because today we are busting a huge myth on Java's memory management. Reference counting sounds very smart, right? But it has a fatal flaw. Java was wise to avoid it. Imagine you are in a sinking boat and furiously scooping out water, but the hole at the bottom of the ship, it just keeps filling up the water in the boat. No matter how hard you work, but the boat will be sink. Yes, this movie said. Yes, on year 1912, the Titanic was claimed by its builders to be practically unsinkable because it was the largest Olympic class ship. However, most of us have the unforgettable memories when in the movie we saw the Titanic hit on the iceberg and impact damaged its water weight components at the bottom. Titanic broke apart and sank to the bottom of the ocean forever. Now, what if I told you this is exactly how reference counting in Java works? It's completely broken your program if you rely on it in every situation. What reference counting actually is. Imagine you have a shared document and every time someone requests access, we add a counter. When the counter hits zero, the document would be deleted because no one is getting shared. Sounds very simple, right? Well, not so fast. In this example in Java, object P equals to new integer 57 and object P Q will have the reference of object P. Now both P and Q reference the same object. Now in this example, each object keeps track of how many references point to it. JVM implementation of reference count of this code snippet gives you complete idea how reference count increases and decreases behind the scene what I am talking about. In another example, that is second implementation, P and Q are initialized as object P equals to new integer 57 and object Q equals to new integer 99. In this implementation, two integer objects are created finally, right? Each with a reference count 1. Now suppose we assign Q to P using the same code sequence as mentioned here. So what will happen? After this assignment, both P and Q right now point or refer to the same object integer 99. Its reference count would be changed from 1 to 2. And now the reference count of integer 57, what would be? It would be 0, of course, which indicates that it is now garbage. And JVM implementation of reference count of this code snippets give you full confidence that heap.release of P would be invoked in this situation. And similarly, what I said before, when an object's reference count drops to 0, it is immediately removed from the memory. Sounds efficient, right? But here is the catch. What happens when two objects reference each other? You are Java programmers, and this situation might shock you. What will happen? Just think. Exactly in this same example, what I want to say. This is the class A, have a reference A, small a, and public class text. In this A object 1 was assigned a new object of A. Object 2 also have a new object A, and object 1 dot a, that's the properties. Object 2 is assigned, and object 2 dot a, object 1 is assigned. So object 1 and object 2, if I both assign the null, are they really gone for the garbage collection? Boom, we have a problem here, and that's called the circular reference. Both objects reference each other, but no external reference exists here. A reference counting garbage collector would never collect them, and that's why the memory leak would happen. Remember that one. Even though we have a set of object 1 and object 2 to null, they're still in holding on to each other in the memory. A reference counter would think, hey, these objects still have references, so I would not delete them, but in actually it is not. And Java's designer knew this flaw, so they took a very smart approach, which is called the reachability analysis. How it works? In one of my earlier video, I have described it in the shorts. Java starts from the root objects, and these are called the GC roots. There are few types of GC root types, like active threads, static fields, native method calls, JNI calls tags, and it traces all reachable objects through a memory graph. And if an object cannot be reached, that will be eligible for the garbage collection and cleaned up. So there are different type of algorithm are also involved in here. Unreachable objects will be marked and swept away in the mark and sweep algorithm in GC. So what are the key differences of reference counting and reachability analysis? Reference counting is looks at the number, but reachability analysis checks if an object is reachable or not. That's the main difference. In this example, Java garbage collection are showing in action. So if you call the system GC, will that call invoke Java garbage collector immediately? No, it would be called when the memory actually needed automatically behind the scene. So what I understand, Java system.gc does not allow or immediately Java will not invoke the GC to delete the objects when references go to 0. Instead, it intelligently checks if an object can ever be used again in future or not. Why does this even matter in the real world applications? Let's take an example from real industry. Imagine a scenario: memory leaks in large scale Java applications. You are running a Java based web server. Your application handles thousands of requests per second. If reference counting were used, cycles in your cache system that could keep objects live forever. And what? Boom, memory leak, server cached, and after all, business loss. And that's why Java's GC prevent this disaster by actively tracing and eliminating unreachable objects, even those are trapped in these cycles. So if reference counting is flawed, why do some languages still use it? Yes, it is still uses in some cases, just like Python, where it uses reference counting but has a backup cycle detector. Swift uses reference counting for performance but requires quick references to prevent cycles. C++ smart pointers use reference counting but require manual handling of for cycles. Those are the manual. But for Java, the trade-offs were not worth it. So it sticks to reachability analysis and doing the automatic garbage collection. No need to worry about the Java programmer. Let's recap why Java does not use reference counting. It prevents memory leak from cycle. No need for extra counter fields in objects. More efficient memory management at scale. And the most important one is the best suited for modern multi-threaded applications. So what is your final thought? Next time if someone tells you Java uses reference counting everywhere for garbage collection analysis, you can confidently say no, and here is the reasons why in this video. So I hope this cleared up one Java's biggest myth. If you found this useful, drop a comment and hit the bell icon and subscribe for more smarter coding. And let me know in the comments, have you ever faced a memory issues in Java? Let's discuss that. If you want to join with our regular Java and other programming batches, please contact us. Thank you so much. See you in the next session.